My dear students, in this video also I am going to solve some problems in the topic inverse trigonometric functions in the State Board 12th standard syllabus, exercise number 4.5. Prove that, the problem number 5 in the exercise is, prove that tan inverse of x plus tan inverse of y plus tan inverse of z equal to tan inverse of x plus y plus z minus xy z divided by 1 minus xy minus yz minus zx. This one we have to prove. This is the right hand side and the expression in the top is left hand side. We have to prove this side. For that, consider the left hand side. You know tan inverse of x plus tan inverse of y equal to, formula you know, tan inverse of x plus tan inverse of y is tan inverse of x plus y by 1 minus xy. This is the result for tan inverse x plus tan inverse y. Again, tan inverse x plus tan inverse y plus tan inverse of z equal to, this is tan inverse of x plus y plus tan inverse of z, you have to write. This is tan inverse of x plus y is x plus y by 1 minus xy plus tan inverse of z. So this is equal to tan inverse of x plus tan inverse of y. Again this result is, using the above result, tan inverse of x plus y, that means x plus y by 1 minus xy plus z. Tan inverse of x plus tan inverse of y divided by tan inverse of 1 minus xy, that is x plus y by 1 minus xy into z. Again we have to use this tan inverse of x plus y by 1 minus xy plus tan inverse of z, using the result tan inverse x plus tan inverse y. Tan inverse of x plus y by 1 minus x into y. Okay. Now this is equal to tan inverse of, by taking LCM as 1 minus xy in the numerator, you will get x plus y plus z into 1 minus xy by, in the denominator also, 1 into 1 minus xy is 1 into 1 into 1 minus xy is 1 minus xy minus of x plus y into z. 1 minus of x, 1 into 1 minus xy minus of x plus y into z divided by the denominator 1 minus xy. So the numerator in the denominator 1 minus xy and denominator to the denominator 1 minus xy get cancelled. Therefore, you get here tan inverse of x plus y plus z into 1 is z. X plus y plus z into 1 is z plus into minus minus z into xy. That is x by z minus x by z divided by, similarly 1 minus xy minus into plus minus yz minus zx. See, this is x plus y plus z into y, 1 is z, plus into minus minus z into xy is minus xyz. In the denominator 1 minus of xy minus z into y is minus zy and minus zx. That's the required result. Tan inverse of x plus y plus z minus xyz by 1 minus xy minus yz minus zx. This is equal to right hand side. The result is proved for this problem. This is the result for the first problem. Whereas in the second problem, in the exercise, same exercise, Sixth problem is that is if the same problem. Sixth one is if tan x plus tan y plus tan z are equal to pi, then prove that x plus y plus z equal to xyz. This is you have to prove. If the same problem, in the fifth problem, instead of tan x plus tan y plus tan z, it is given as pi, then prove that x plus y plus z equal to xyz. So, you know that this is the result, you know, tan inverse of x plus tan inverse of y plus tan inverse of z is tan inverse of x plus y plus z minus xy by 1. This is the right hand side answer. But this is given as, it is given as in the problem pi. Okay. In the problem, it is given as pi. So tan inverse of this quantity equal to pi implies from this you will get x plus y plus z minus xyz by 1 minus xy minus yz minus zx equal to tan inverse is, it becomes tan pi. What is tan pi? Tan pi is 0. So this quantity, this is 0. Tan pi is 0, you know. From this expression, if the fraction is 0, it means numerator is 0. This implies x plus y plus z minus xyz equal to tan pi is 0. So numerator is 0. And from this expression, you get x plus y plus z equal to xyz. That is our required answer. This is problem number 6. So just a deduction of the problem 5. Okay? Next, we are going to solve the problem 9. In this first subdivision is solve the equation sin inverse 5 by x plus sin inverse 12 by x equal to pi by 2 given. To solve this equation, we have to find out the value x. That is our problem. We have to find the value of x is the solution for it. Sin inverse 5 by x you consider as a. Therefore, sin a equal to 5 by x. That is sin a equal to 5 by x, opposite by hypotenuse. So adjacent side is root of x square minus pi square. That is x square minus 25. So from this cos a equal to adjacent by hypotenuse. Adjacent side is root of x square minus 5 square is 25 by hypotenuse is x. This is cos a. Similarly, sin inverse of 12 by x you consider as b. From this 12 by x equal to b. Sin b I mean. Sin inverse of 12 by x is b. So 12 by x is sin b. So for this also you will consider this problem b. Right angle triangle. Sin b opposite by hypotenuse. Opposite by hypotenuse. From this adjacent side is root of x square minus 12 square. That is 144. From this cos b equal to adjacent side. Root of x square minus 144 by hypotenuse is x. This is cos b. So sin inverse of 5 by x is a. This is a. Sin inverse of 12 by x is b. This is b. So a plus b equal to pi by 2. So from this we get a plus b equal to pi by 2. Taking cos operation, cos of a plus b equal to cos pi by 2. You know cos 90 is 0. Okay? This cos 90 is 0. Therefore, cos a plus b, you know, cos a cos b minus sin a sin b. Cos a cos b minus sin a sin b is cos 90 0. Now you substitute the values for cos a. Root of x square minus 25 by x into cos b. Cos a cos b root of x square minus 144 by x. Cos A cos B minus sin A sin B. Sin A 5 by x. Sin B 12 by x equal to right hand side 0. So, after operation with cos on both sides, cos A plus B equal to cos A cos B minus sin A sin B is cos 90 0. Cos A cos B minus sin A sin B, values are cos A cos B minus sin A sin B. Now, numerator x square minus 25 into x square minus 144. Equal to, this is by x square denominator. Here 5 tables are 60 by x square. You take that 60 by x square on the right hand side, x square both in the denominators get cancelled, you will get a root of x square minus 25 into root of x square minus 144 equal to 60. X square gets cancelled on both sides. Squaring both sides, x square minus 25 into x square minus 144 equal to 3600, 60 into 60. Now you multiply these equations, these two terms in the left hand side. You will treat x square by y. Substitute x square by y, you will get y minus 25 into y minus 144 equal to 3600. From this you multiply these two. After replacing x square by y substitution, you give a substitution for x square equal to y, you will get y square. You multiplying these two, you will get y square minus 144 minus 125 minus 169y plus 25 144 is 3600 equal to the right hand side 3600. They get cancelled, you will get y square minus 169y equal to 0. So this equation becomes y square minus 169y equal to 0. And we will solve this equation afterwards. Okay? Now y square minus 169, you take y as common term, you will get y minus 169 equal to 0. Y minus 169 equal to 0. From this, y equal to 0 or y equal to 169. What is y? Y is x square. So from this, x square equal to 0 or x square equal to 169. See, from this, x equal to 0 or x equal to plus or minus 13, you will get x equal to 13 is our record answer, solution. X equal to minus 13 not possible. So x equal to minus 13, x is positive, therefore x equal to minus 13 your answer. X is equal to minus 13 is impossible. That's all about the problem. See, next problem, solve 2 tan inverse of x equal to cos inverse of 1 minus a square by 1 plus a square minus cos inverse of 1 minus b square by 1 plus b square. Here, you treat that a is tan a. A equal to tan a. From this, a is tan inverse of a. If a equal to small a equal to tan of capital A, then tan inverse of small a equal to capital A. Okay? So, in this expression, cos inverse of 1 minus a square by 1 plus a square, if you rewrite this as cos inverse of 1 minus a is tan a, tan capital A, that is 1 minus tan square a by 1 plus tan square a. 1 minus tan square A by 1 plus tan square A. This is equal to cos inverse of cos 2A. Trigonometric result 1 minus tan square A by 1 plus tan square A is cos 2A. So cos inverse of cos 2A is 2A. That is equal to 2 into A is tan inverse of A. Okay. Similarly, you substitute B for tan B. B equal to tan B. So tan inverse of small b equal to capital B. From this expression you will get cos inverse of 1 minus b square by 1 plus b square is cos inverse of 1 minus tan square b by 1 plus tan square b. That is equal to cos inverse of cos 2b, that is 2b, that is 2 into b is tan inverse of small b. So the problem now reduces to tan inverse of x equal to cos inverse of 1 minus a is 2 tan inverse of a plus cos inverse of 1 minus b square by 1 plus b square is 2 tan inverse of b. 2 you cancel on both sides, you will get tan inverse of x equal to tan inverse of a plus tan inverse of b is tan inverse of a plus b by 1 minus ab by formula. Tan inverse of x plus tan inverse of y is tan inverse of x plus y by 1 minus x by formula. Tan inverse of a plus tan inverse of b is this. And eliminating tan inverse on both sides, you will get x equal to a plus b by 1 minus a. That's all about the problem. Okay. Next problem. Solve 2 tan inverse of cos x equal to tan inverse of 2 cosecant x. To solve this problem, consider the left hand side first. 2 tan inverse of cos x is expressed as tan inverse of cos x plus tan inverse of cos x. That is equal to tan inverse of x plus tan inverse of y is tan inverse of x plus y cos x plus cos x by 1 minus xy cos x into cos x. By formula, tan inverse of x plus tan inverse of y is tan inverse of x plus y by 1 minus xy. Using this idea, you get tan inverse of 2 cos x by 1 minus cos square x. That is equal to tan inverse of 2 cos x by sin square x. 2 cos x by sin square x. 1 minus cos square x is sin square x. Now the problem becomes left hand side is tan inverse of 2 cos x by sin square x equal to tan inverse of 2 cosecant x. So tan inverse of eliminating both sides, you will get 2 cos x by sin square x. 2 cos x by sin square x equal to 2 cosecant x. 2 cancel on both sides, you will get cos x equal to 2 cosecant x into sin square x. Cos x 2 cancel on both sides, cos x equal to 2 cosecant x into sin square x. Cosecant x is 1 by sin x into sin square x. You multiplying the sin x to the left hand side, you will get sin x into cos x equal to sin square x. You bring entire things to right hand side, you will get sin square x minus sin x into cos x equal to 0. Sin square x, the term, when you bring it to the one side, you will get minus sin x into cos x equal to 0. Taking sin x as common term, you will get sin x into sin x minus cos x is 0. From this two expression you will get sin x equal to 0 or sin x equal to cos x. That is sin x minus cos x equal to 0, that is sin x equal to cos x. Sin x equal to 0 implies x equal to n pi. Sin x equal to cos x implies x equal to n pi plus pi by 4, because sin 45 equal to cos 45. Therefore, x is pi by 4. By trigonometric equation results, x equal to n pi plus pi by 4. This is x equal to n pi. In both the cases, n belongs to the integer system, z. Okay? X equal to n pi or x equal to n pi plus pi by 4 is the solution for this problem. That's all about the exercise 4.5, and thereby we conclude the topic inverse trigonometric functions in this video, and we will start the new topic in the next video. Thank you.